So last time we spoke a little bit about logarithmic functions and their domain, but today we're also going to talk about the x-intercepts and the asymptotes of logarithmic functions. But let's take a look at how they shift first. So if we want to add 4 to the logarithm inside the logarithmic function, we see that it actually shifts 4 units to the left, which is opposite of what we would think because we're adding 4. But let's actually subtract 4 and see what happens then. When we subtract 4, it shifts 4 units to the right. So if we're talking about inside the function and adding or subtracting, it actually moves the opposite way. Now let's take a look at what happens if we do something to the outside. If we add, let's say 5 to the outside, it shifts 5 units to the right. Up. And if we subtract 5, it shifts 5 units down. So we can actually see that logarithmic functions follow the same transformations as other functions as we discussed before, and it moves left or right, the opposite of what you would think if it's inside the function, and up and down vertically, respectively of if you're adding or subtracting. But now let's actually take a look at the whole vertical asymptotes. For the vertical asymptote, as you can see in this function, there is a vertical asymptote at x equals 0. And that is because the logarithmic function approaches 0 very, very close, but as we saw last time, it can never touch 0. It has to always be greater than 0. That's the domain. But now let's see if we shifted over the function, let's say 3 spaces. If we shifted it over 3 spaces, the vertical asymptote now shifts as well. The vertical asymptote is now at -3, and the domain is going from -3 to infinity. So shifting the function also shifts the vertical asymptote. And the same thing can be true if we shift the graph over to the right. If we shift the graph over to the right to -6, then our vertical asymptote is at x equals 6. So at x equals 6, the graph, the new domain for this graph is anything that is 6 or greater. So from 6 to infinity. So there is a relationship between the domain and the vertical asymptote. And that relation is that the greatest or smallest point of the domain is your vertical asymptote.
So let's say we were taking a look at an example and we wanted to state the domain, vertical asymptote, and x-intercept of f of x log base 3 of -4x minus 5. So remember that to state the domain, all we have to do is look at the inside of the function. So we want to set that we want to set that greater than 0. So we can take -4x minus 5 and set this greater than 0. And we just solve for x. So solving for x, we can add 5 to both sides, and then what we're left with is -4x greater than 5. So solving for x, divided by -4, divided by -4, and what happens to the sign once we divide by a negative? It flips, so we have that x is less than 5 over -4. In interval notation, this is just -infinity to -5 over 4. And so since -5 over 4 is the biggest it can be, then there is a vertical asymptote at x equals -5 over 4. And remember that the vertical asymptote is a line, so you have to write x equals -5 over 4 as a line. To solve for the x-intercept, we know that we want to set y equal to 0. And in this case, our y is just f of x. So we want to let f of x be 0. So we're going to have 0 is equal to log base 3 of -4x minus 5. And we want to solve for x. But that seems a little complicated in this form. So let's actually switch from logarithmic form to exponential form using that change process. And so what that means is that we're going to actually have 3 raised to the 0 power equal to -4x minus 5. And so we can actually just solve for this. We know that anything to the 0 power is just 1, And so that is equal to negative 4x minus 5. Solving for x, all we have to do is just solve it like a regular equation. So add 5 to both sides, add 5 to both sides. We have 6 is equal to negative 4x. We can divide by 4, divide by negative 4. And we have that our x is equal to 6 over negative 4. Simplifying this, because we have to simplify fractions, we're left with 3 over negative 2. So our x-intercept, since it's a point, our x-coordinate is negative 3 over 2, comma 0. I can switch the negatives either in the numerator, denominator, or in the middle. Anywhere is fine, as long as you just have one. Okay, so this is our x-intercept. And so solving for any kind of logarithmic function where you want to find the domain, vertical asymptote, and x-intercepts always follows this same procedure. So you can do this for any kind of equation with logarithmic form.